Hey, this is a Mathketeer here to show you how to simplify radical expressions. When simplifying radical expressions, you first need to factor out the perfect squares, leaving the remainder under the radical sign. When dealing with variables, you divide the exponents by 2 and leave the remainder of exponents under the radical sign. It is also very helpful to know the perfect squares from at least 1 through 10. You can use these numbers to check the divisibility of the numbers you're trying to simplify. I have 6 examples here to help illustrate. Example number 1 is the square root of 125x. Now I can see that 25 will go into there evenly 5 times. So we can rewrite this, the square root of 25 times 5 times x. The square root of 25 is 5, so we can pull that out, leaving 5x under the radical sign. For example number 2, we have the square root of 100x cubed. We know now that the square root of 100 is 10. Quick look at x cubed. We divide 3 by 2, and we can pull out 1x, and we have 1x left inside the radical sign. For example number 3, we have 80x cubed. I want to look at all the perfect squares that are even numbers. 64 will not go into 80 evenly. 36 does not go into 80 evenly either. But if you look at 16, it goes into 80 evenly 5 times. So we can rewrite this, the square root of 16 times 5, and now we have x cubed. We can pull one of the x's out. The square root of 16 is 4x, and we are left with 5x under the radical sign. For example number 4, we have the square root of 45x squared. I know that 9 goes into 45 evenly, so I can rewrite this, the square root of 9 times 5 times x squared. The square root of 9 is 3. The square root of x squared is x, leaving just the 5 under the radical sign. For example number 5, we have the square root of 512x cubed. A quick look at our perfect squares, and we can see that 100 will not go into 512 evenly, so we will check 64. When we divide 512 by 64, we get 8. So we can rewrite that as 64 times 8 times x cubed. Now we can also factor 8, and we can do it this way, 64 times 4 times 2, again, x cubed. So 64 is a perfect square, and 4 is a perfect square. So we can pull out 8 times 2, and then we can pull out an x, and we are left with 2x under the radical sign. 8 times 2 is 16, and our final answer will be 16x times the square root of 2x. See what I did is I factored out 512. I found that there were 2 perfect squares, 64 and 4. The square root of 64 is 8. The square root of 4 is 2. We multiply those 2 together. 8 times 2 is 16. We have x cubed. We divide by 2. We get 1x comes out, and 1x remains. For example number 6, we have the square root of 147, x to the 7th and y to the 5th. We will now look at our odd numbers for perfect squares. 81 will not go into 147 evenly. However, if we divide 49 into 147, we get 3. So we can rewrite this 49 times 3, x to the 7th, y to the 5th. The square root of 49 is 7. We divide x to the 7. We divide 7 by 2, and we get 3 with 1 remainder. We divide y to the 5th, we divide 5 by 2, and we get y squared with 1 remainder. So we can pull out 7x cubed y squared, and what's left under the radical sign is 3xy. So, when simplifying radical expressions, again, it is helpful to know your perfect squares at least from 1 to 10. You factor these perfect squares out of the number, leave the remainder under the radical sign. You follow the same for the exponents. You divide by 2, leave the remainder under the radical sign. I am the Mathketeer. Thanks for watching. Please subscribe to my channel and leave a comment. Let me know what you think.